私はテドハンです。はじめまして。3年、日本語は3年勉強しましたけど、全部忘れました。使えないからすみません。それで英語でいいでしょう。Um, uh, I'm going to go somewhat quickly. So if anyone would like to download my slides to follow along, you can find them either at that cloudy link there, or you can just get them off of my Twitter profile here. It's the, I think, third to top link at this point. Um, so I'm going to be speaking about DataMapper and data mining today. DataMapper is a data access library, which some of you may be familiar with. You can use it to integrate with Rails 3. However, you can also use it as a standalone library, which is primarily what I'll be talking about. And I'm going to start with a minor digression, which is that back in the 1800s and the early 1900s, during the Industrial Revolution, the labor movement started pushing for a clear division between what was the purview of a workman's requirements for work versus how much time off they have and how much time they have to rest. So you end up with a division that looks something like this. Now, our economic input basically was supposed to be the 8 hours that we give to our employer, which we trade basically our time and expertise for our wages. And then, of course, we had 8 hours to rest, and then 8 hours to do as we will. But since the digital revolution has really started, we've seen a marked change in what our economic input is. So it's no longer the case that we just make money and that's how we drive the economy. People care now about all sorts of different business analytics and analytics about what you buy, where you're going, what it is that you do on a daily basis. So it turns out that this actually becomes an important driver for the economy. The problem is that this is sort of snuck up on a lot of people, and people don't necessarily know who collects their data, what sort of data is being collected, and they don't necessarily consider what it is that you're getting in return for giving up information about you. Obviously I'm talking to a technical crowd, so many of you probably are aware of some of the details inherent, but your family may not necessarily, or friends of yours may not know when they're, say, sharing things on Facebook, or scrobbling things to Last.fm, or what they're purchasing on Amazon if they're sharing their account with someone. A lot of these companies, for example, do actually provide you something in exchange for your data. Google's entire bottom line is based off of advertising primarily, but they produce a lot of very interesting products that mean that I never have to maintain my own mail server ever again, which I greatly appreciate. Amazon obviously does do a decent job of suggesting things that you may want to buy. Facebook, I don't know. Your mileage may vary. So companies benefit directly from the sort of data that they collect on us when we use their service, and their primary bottom line is to try and get that information and then be able to ask questions about who we are and what it is that we do. So we can benefit indirectly from the services they provide us, but the question is, why can't we benefit directly from the data that we collect? Companies like Google do provide you a lot of services, but you don't necessarily have raw access to all the information that they take from you. But if we're crafty and we know where to look, we can actually draw some conclusions about our behavior just the same way that they would. And fortunately, Ruby can help. The basics for data mining are basically you want to try and figure out what your problem is, collect all the data that you need to try and explore what the topic of discussion that you want to look at is, and then go ahead and figure out what specific aspects of the data set you're looking at are. That's the querying aspect. And then the manipulation is in case you need to make any modifications or clean up your data in any way. And then you try and draw conclusions from the data set that you've specified via querying. So my tool of choice here is DataMapper, which allows me to do all of these things. Um, uh, I'll just recap really quickly some things about DataMapper. DataMapper is normally thought of as an ORM. It's a little more complicated than that in that you can map non-relational data as well. So you can use it as an ORM, connect to Postgres, MySQL, etc., SQLite, and the like. But you can also connect to things like Bigtable, an App Engine, or various other non-relational stores, or things that aren't even canonically known as data stores. So for instance, there's an RDF adapter. There's a somewhat old Sphinx adapter that would allow you to query a Sphinx index as opposed to another sort of data store. So there are many things that I've always wanted to know about myself and my browsing habits. So I was thinking it would be really great to get my search history and look through it, but unfortunately Google doesn't provide an API to this. They provide APIs to a lot of other stuff like your YouTube followings and all that sort of stuff, what you've posted, but frankly I don't upload all that many videos. So the next best thing I could go for was my Chrome history. I'm a Chrome user and figured out, well, you know, they're actually just using a SQLite 3 database to store all of the information that they're tracking within Chrome. And you can find your Chrome history at this location. Make sure you make a copy of your history, because if you have Chrome open and you're also messing with it, there's always the possibility that you'll corrupt it. So back to the question at hand. Once you have a data source, you should ask yourself 3 questions when you're trying to figure out whether you can extract data from it. In particular, if you're using DataMapper. The first question is, does a DataMapper adapter exist for it already? And if it doesn't, then can you write an adapter for it? And then lastly, if you can't do any of those things, can you write a scraper to import it into another database? So this is the data preparation step, and you need to be able to get access to your data and query it. So in this case, does a DataMapper adapter already exist? Yes, it's just an SQLite database, so that's quite handy. What I went ahead and did then was simply just open up the SQLite database, interrogate what the schema for the database looked like, which in this case for this table, the URLs table, which is what we're primarily concerned with, just looks like this. Now, there is a library that's currently being written by one of DataMapper's core contributors that will allow you to actually reflect on existing databases and map the structure out of that, but it's not quite done yet, so I did this by hand. So you can see here that the structure is pretty simple. You've got an ID, which is the primary key, URL, title, visit count, type count, last visit time, and then some other stuff that we don't really care about. So the things that we primarily care about here probably are the URL, the title, visit count, and the last visit time. So here's my naive attempt. Initially, when I was writing through here, I just wanted to go through, make sure that I got all the fields mapped correctly. And you'll notice with DataMapper that these two map up pretty closely initially. And you'll also notice that all of this stuff is declared inline inside of your class file. So the model is very explicit. You see all this stuff. If you receive somebody else's model, you can look at it. You know what's there. And then you'll notice over on the right-hand side here, there's a number of inline validations. There's a separate library that you use typically with DataMapper called DM validations, which provides you with a bunch of these constraints, which, as you can see, map very closely to what we can see in the database. The nice thing here was, okay, this was fairly simple. I went ahead and gotten this working. So I was like, all right, well, I'll fire up IRB, import all this stuff. The schema basically match. Let's see what happens. Okay, so we pull up the first URL, and as you can see here, I was looking for RubyKaigi. You know, the object returns just fine. All the fields are being marshaled properly. So we've got rubykaigi.org is the URL there. There's a title. There's a visit count. So you can see that there's, you know, approximately 50,000 URLs. And I went ahead and tried to do a sanity check and noticed that for some reason there are 20 URLs in this database that have no view counts. How they got there, I don't know. Most likely there's a bug in Chrome. But it's always good to check these things, because then you can realize that actually there's some business rule validations that we should add in here too. So the other nice thing about DataMapper, besides these database constraints, you can add additional validations that get run, of course, at when you save, and you can use some of the default things like format, which will make sure that your URL is correctly formatted, or that the visit count shouldn't need be above 0 if it's in the database. Of course, down below, I forgot to mention that you can see the relationships are just declared in line here, and you can see those map to other models, which I have neglected here, but I'll post when I post the rest of the code. We start here with some data manipulation. So we went ahead and did the naive types through all of this stuff, and then we figured out, well, actually, if we head back up here, you can see that what's being returned as the URL for this object is just a string. And it would be nice if we could actually query that and get more information about that, break it up. Since URLs are obviously fairly uniform across all possible inputs, you can go ahead and write a class, or in this case, we can actually use a built-in class that comes with another DataMapper library, which allows that to be marshaled when it gets pulled from the database to a different Ruby object within your record. And the handy thing about that is that you can go ahead and query your object and then pull out the URL and do other things like just pull out the host versus the protocol or the path or the query string or whatever. And the great part there is that if you want to just change part of the URL, the URL object goes ahead and manages all of that sort of state stuff. And then once you save the object, it just writes it down, marshals it to a string, and then puts it back in the database. So you'll notice one other thing up here. If you look at the top object here, we've got all these properties on here, title, and then the last visit time is this huge freaking integer. So I was kind of curious about what on earth that was, especially since that would be a useful piece of information to actually have. So I went ahead and looked at the database and went, well, that's not really going to help me any, is it? And so I had to actually resort, and this is of course typical for data massaging, you have to go figure out what the source was that generated this and what it exactly was that they intended, since we can't get any clues here. So I happen to have a copy of Chromium checked out. I went ahead and searched around through the source and found out that actually they're storing all of the times as microseconds since the epoch, which was mentioned earlier, which I think happens to be 1970 something, and on Mac OS, and you can see it's platform specific here. So I went ahead and grabbed that and noticed that handily they have a bunch of Ruby code to indicate what they would have liked. So the nice part about that is that I can just go ahead and write myself another custom type, which you can just insert here as a property, which otherwise behaves exactly the same way you would expect an integer to behave on the database side, but on our side gets marshaled to a time anytime you want to use it, and then can be marshaled back down when you if you want to change it and save it. So in that case, we can do cool things like, all right, you can see here that this result actually does return as a proper time. And the reason why this is important is once you've actually massaged your data into a format that you would like, then you can do fun things like build histograms of when URLs were stuck in here. In this case, I'm actually using the visit model, which is a join table on the URLs to say when each URL was hit when. Here's the part where you get to learn a little bit about me. This was, again, taken from my Chrome history, and you should ask yourself, over what time span was this taken? So this was from the end of May until the end of August, so about 3 months. This is my browsing by hour. Now, if you remember what the labor movement was aiming for, was about 8 hours of work, 8 hours of rest, and 8 hours to do whatever the heck you want. So I think from this you can tell what time I get to work, and approximately what time I stop, which isn't quite 8 hours. And then also you'll notice that none of these bins actually have zeros in them. And that's because I work with people in Britain, so sometimes I'm up very early in the morning, either because I haven't gone to sleep yet or because I've gotten up early. Now, these histograms are pretty easy to generate. And so I went ahead and said, all right, well, are there any specific URLs that are more representative of browsing history, and I figured this one would be a good one. I was wondering if this particularly correlated with work. And again, you can see that building the histogram is very easy, and then you can just dump it to whatever program you want and go ahead and build a histogram. So in this case, I was just using numbers. So RubyDoc, of course, you can see also follows a very similar pattern where, I'm mainly hitting RubyDoc in the morning, a little bit in the afternoon here and there. Maybe there's a bit of a coma there after lunch. And then there's me panicking at 3 a.m. trying to figure out how string works. So I mean, it's pretty easy to go ahead and use these tools to grab existing data sources and learn something about yourself, learn something about others, things like that, if you can get their Chrome history. Then the next question is, this example is pretty well behaved. You have an SQLite database, you can pull stuff from it. DataMapper is already pretty well defined in this space. It behaves quite well relationally. So what happens when you have a source which isn't well behaved? And this particular example comes from an Ars Technica thread that a friend of mine linked me to, which was, does the edge have an anti-PS3 bias? So a flame war had broken out over whether this particular review outlet, Edge magazine, was reviewing PS3 games negatively. And the thing that you learn from being on Ars Technica is that there's this huge division between PS3 fans and Xbox fans, and they're always sniping at each other. And so this was a very typical example of the sort of thread that breaks out. But the difference here was that my friend Raja Doak, who's an author and gamer, happened to be in the thread and said, we can actually learn something about this here. So people were in particular complaining that Edge's review scores were typically lower than the meta scores for the games that they were reviewing. And helpfully enough, the title of the thread actually is a testable hypothesis. So we can go ahead and say, are review outlets' aggregate game scores similar or dissimilar? We have to pick one, of course. So we'll go with similar to the aggregate metascore for the same games that are being reviewed. And this is interesting because this is exactly the sort of question that you can answer very easily if you have the data. Unfortunately, Metascore has no API. So they've done a better job of putting a bunch of this information up, but since they have no API, we have to resort to the poor man's API, i.e. HTML scraping. And again, this when you're preparing your data, again, there's no DataMapper adapter for this. We can't really write one. We could, I suppose, write one-off for Metascore, but if they change anything, it breaks, so it's not really worth the effort. So in this case, HTML scraping. Save me, Nokogiri. So that's the scraper script. Indeed, not very pretty. But it works, so I heart Nokogiri. Thank you, Tender Love, and don't know if you're here or not, but and then the models for this are also, I mean, you can't really read these here, also pretty simple. Most of these actually, a few of them aren't used. The developer one down here, I don't use at all, and then the other three are basically just through relationship between games and review outlets with reviews in the middle. And so what we wanted to do was check whether the average scores, basically the distribution between Metascores and the review scores were any different. So what we used was students t-test. Now, this is obviously very clearly an analysis tool. Once we've actually scraped all of the data from Metascore, we basically have it in the format that we want, since the scraping stage is also the preparation stage, more or less, when I'm inserting it in the database. That way I know that I've got good data in my database, and we can just move directly on to the analysis stage. Now, this was, basically a direct translation of what all statistics books say about students t-test. But the one difference here is that I've written this specifically with DataMapper in mind. So what you can do is you just basically hand this a property that's on a collection and then the collection that it's supposed to apply to. And you can do this with basically any two DataMapper collections. So this is now general enough that I can take this to any data set that I want, any set of models, whatever you want, so long as I can get a collection and it's got a property on it that's an integer. I suppose I probably should have type checked that, but I haven't in here. Then this will work and I can generate a t-test for it. I mean, obviously it's not going to be meaningful in some cases, but this is, now that I've written this once, anything that I can get access to through DataMapper, I can use this on. and whether that's a web app or, again, doing more analysis through my own personal stuff. So here we have the aggregate, all the PS3 reviewers and their scores compared to the Metascore. And what you'll notice here is that, okay, so there's 140 of them that were in this particular set. We didn't grab all of them, I don't think, but we grabbed, or actually I think we may have grabbed all of them at the time. This was a year and a half ago almost. And you'll notice that actually we end up with 30 review outlets that actually deviate from the Metascore. So that means that they're significantly different in either one way or the other. So if they're low, that means that they are more negative than the Metascore, and if they're high, that means that they're, of course, higher, and that means that they're actually more favorable than the Metascore. So we can also compute the same thing for the Xbox 360 outlets as well. I mean, you can see that the code's almost interchangeable. The only thing that I've done different is, specify what platform is being used here. And then you can see that the set's slightly larger, and a greater number deviate from the mean, or Metascore in this case. But also you see the same pattern, that there's more review outlets that are negative than there are positive compared to the mean. But by and large, I think there was quite a number more that just didn't meet significance, and that means that they're basically the same as the Metascore. So then the question is, what about Edge Magazine in particular? Well, it actually turns out that Edge Magazine has no negative bias against the PS3, and you can see from the score that they've got, they're actually higher than the Metascore. So they're actually pro PS3 as opposed to negative. And this just shows that there's a lot of confirmation bias, and the useful part about doing data mining is that you really should check the assumptions that you've made. And, humans really are pattern recognizing or generating, as the case may be, devices, and sometimes they definitely do go awry. So in this case, it was very much worth it checking this, and the thread ended up being significantly more productive than it would have otherwise been had we not been able to get some of this information. So there's a lot of possibilities. DataMapper is really useful for this sort of stuff. And again, once you generate some of the code that you can use to do these analyses, that can be reused in a variety of contexts, either web apps or, again, other sorts of apps. I think this is an underappreciated part of, at least in the US and I guess Europe as well, people don't necessarily poke around with these sorts of things and distribute these sorts of tools, even though that there is a lot of opportunity to look at interesting information. So there's lots to learn. Please go out and do so. There's, maybe you would like to learn about DataMapper. You can, of course, hit the website or IRC. There's always lots of people there. Everybody is very friendly, so they would certainly offer to help out if you have any questions. So. Thank you very much.
Two more questions, because the keynote speech of Matt will be started at 11. So, any questions?
Yeah, in your example of DataMapper, you gave having custom DataMapper classes like the URL or the Chrome time. And in those examples, it mapped between one column in the database to one object.
Yes.
Can you have multiple columns in your data source, like in your database, mapped to one object through DataMapper?
That is the embedded value pattern, and we have not implemented that yet, but that is on the roadmap.
Okay, cool. Thanks.
Oh, additionally, if anybody would like to catch me later, you can feel free to reach me here. So please do.